All right, let's get back to action. I know that folks have enjoyed that break after a riveting keynote by Mr. Tom Whitmire earlier today. I'm hoping that folks who were in that session can share a highlight or two in the chat. What's something that you remember, you took away from Mr. Whitmire's keynote? For myself, I'm reflecting on how he discussed the challenges in combining and distributing data in the modern age. As opposed to 20 years ago, the problem is not generating data, he says, but managing that data, sharing that data in a reasonable fashion. He talked specifically about how blockchain could be beneficial for Earth observation data and part of the solution of that challenge of having so much useful data. I really appreciated how he left that conversation, acknowledging that there are major advancements to come in space technology over the next 5 or 10 years, and that it's up to us, the global community, to think about how we can get involved, how we can stay on top of these technological advancements, and find ways outside of specifically technical arenas to use our skills, use our abilities, use our creativity to help be a part of the solutions to the challenges we face. So again, thank you, Mr. Whitmire, and thank you all of you for joining his keynote presentation. So let's talk a little bit about why we're all here today. The NASA Space Apps Collective is a sister program to the Space Apps Hackathon Challenge, wherein we invite a cohort of engaged citizens from around the world to participate in year-round skill building in support of our theme, empowering change through science and community action. As we will do throughout the summit, we want to highlight some of this year's collective cohort. So now we'll have Cynthia, the Global Community Manager for the collective, spotlight some of our cohort. Cynthia?
Thanks, Parker. Now let's continue highlighting some remarkable members of our collective cohort who are driving innovation in space, AI, and interdisciplinary collaboration. Each of them brings a unique perspective, leveraging open science and global connections to push boundaries in their respective fields. Today, we're excited to feature two more inspiring individuals. Let's meet them. Yuang Teo is passionate about collaborative learning and knowledge exchange. For him, the collective has provided a rare opportunity to engage with top minds from around the world, including NASA subject matter experts. He values the ability to exchange ideas with a global network and gain insights that broaden perspectives and fuel innovation. From fostering global collaboration, we now shift to the intersection of AI, life sciences, and space exploration with our next spotlight. Kirtana in Sri Lanka sees the NASA Space Apps Collective as more than just a platform. It's a journey into the unknown, an opportunity to push the limits of innovation and connect with like-minded thinkers. Through every collaboration, she sharpens her skills, broadens her perspective, and moves one step closer to making meaningful contributions to space science. Her work embodies the belief that curiosity and collaboration unlock endless possibilities. With that, I'll send it back over to you, Parker.
Thanks so much, Cynthia, and thank you so much to our cohort for their year-round engagement and support of open science. So we're wrapping up our first block of programming with an awesome panel of NASA subject matter experts who will share how they use open science to empower communities. Then, after a break, we'll resume with lightning talks from some of our collective cohort who will share about the projects they've been working on throughout this year. As a reminder, our Summit Navigator will be active in the chat, sharing links and resources. They're here to help you find your way through this virtual experience. Before we dive into the panel, I want another opportunity to energize our crowd online and help us get familiar with the WebEx technology that we'll be using. WebEx is our official Summit platform, and we encourage people to use the chat to comment and communicate. So take a moment, if you haven't already today, to introduce yourself in the chat. You include your name, where you're from, contact information that you want to share, but please limit that to social media, nothing more specific, nothing more personal than social media handles, please. See folks joining from India, from Argentina, from Bangladesh, from Maryland, from Spain, Morocco, Egypt. Always amazed by the global community that we've created here in the NASA Space Apps Collective. We want to still learn more about you, so in the chat, let's move to our next warm-up question. Type one aspect of space or earth science that's most fascinating to you. What are the most fascinating aspect of space or earth science? Speaking for myself, and although I don't really understand how it works, quantum computing to me is so interesting. I hopefully will continue to build some skills around it, but for now, just the idea that we can, have telescopes that are much more accurate and communicate over vast differences more quickly, I think has a lot of potential for advancing space science over the next few years. I see folks sharing remote sensing, black holes, a, a lot of black hole fans in the chat, which I get. Thanks, folks. We're glad that you're taking this opportunity to get to know each other and help us get to know you a little bit better as well. Without further ado, let's get into this panel. As a reminder, the question and answer function is available for you under the chat, where you can offer some questions that we'll raise and ask to our panelists. You can also use the reaction button to offer quick reactions and emojis that kind of capture your excitement about what these folks are sharing with us today. In this panel session, we'll be discussing how NASA empowers action through open science and citizen engagement. We're joined by Marc Kuchner, Kevin Murphy, and Marilé Colon Robles, who all are NASA subject matter experts. To our audience, I remind you, use a Q&A function, and we'll get to those questions as time allows. Without further ado, I'd like to invite our panelists to the stage. Hi, all, and thank you so much for joining us today. I'd love to have you introduce yourselves to let our audience know where you work, the kind of stuff you contribute to at NASA. Kevin, would you like to begin?
Oh, sure. Thanks for the intro and really happy to be here. You can all hear me, right? Sound check? Okay, good. Yeah, so Kevin Murphy, I'm the Chief Science Data Officer at NASA's Science Mission Directorate. And, I'm, like I said, really happy to be here today. My job is to really look across all of the science divisions within NASA and make sure that we collect the data and make it available to people to use around the world. So I've got probably the best job in the world because we get to do all the scientific work and working with communities to make this data available for folks. Let me just tell you a little bit more about myself. My background is earth science. So I started doing land cover remote sensing a long time ago, but I found it so hard to get that data that I decided I'd go fix the systems that distribute it, manage it, and process it. So I've been part of space apps, I think, since it began, maybe 10 or 12 years ago. And we had a couple of really good challenges with like visualizations of data from our Worldview client and Gibbs and things like that. And so I'm really happy to be back here in this capacity. Um, so we've got a lot of data. We've got over 100 petabytes of data, which is like maybe 24 million HD movies worth of data.
Wow.
So a lot of data. We get more data in all the time. We make it available for folks, especially like this community who's incredibly innovative on how they use that information to make new discoveries. Of course, AI is a big part of what we do, and I'll talk about that a little bit later. But yeah, thanks for the intro, and look forward to the discussion today.
Thank you so much. Marilé, would you like to go next?
Sure, thank you so much. I'm excited to be here. My name is Marilé Colon Robles. Hola a todos aquellos que hablan español. I had to say it in Spanish as well. Hello. I am the project scientist for cloud observations for the GLOBE program, and GLOBE is NASA's largest and longest lasting citizen science program about the Earth. We're about to celebrate 30 years, and with that comes a lot of data, thanks to many of you who are part or have been part of the GLOBE program, either as students, educators, or just citizen scientists using the GLOBE Observer app. So thank you for your observations. In my role, I get to compare or co-locate your cloud, sky and cloud observations to satellite data. Here, working with the Atmospheric Science Data Center at NASA Langley Research Center in Southern Virginia, which is where I'm at. So it's very exciting to be working with over 120 different countries and researchers looking at how clouds look from space down in a satellite's perspective or remote sensing perspective, and from the ground looking up. There's different advantages to both views, and our team merges those views for you all. A little bit about me. I am not from Virginia originally. I'm from San Juan, Puerto Rico, so that's why my name is in Spanish. And I talk with my hands, so I'll try and reduce the movement of my hands, but I'm an avid volleyball player, which I still do here at NASA, and I am a wife and I have 2 daughters. So very excited here to be talking to you about clouds in the GLOBE program. Thank you.
Thank you. We're so glad you're able to join us today. Mark, how about you? You'd like to do an introduction for us?
Sure. Thanks, Parker. Hey, I'm Marc Kuchner. I'm an astrophysicist. I just did my own science at NASA. I had my own research group. I Goddard Space Flight Center for about 15 years. Then I did an experiment inviting new people that I'd never even met to science with me. And my gosh, I am hooked. Um, it's my new favorite way to do research. And I was so grateful when I was invited to come to headquarters. And my new job is to do awesome NASA science with as many people as possible. I connect scientists and volunteers and scientists. And so now I get to help out over 31 of NASA citizen science projects. Each one of them, we have projects in each one of the 5 different science divisions, and we do really cool stuff, and I can't wait to tell you more about it.
Thanks, Mark. We're excited to hear about it. I think, so for this next question, I want to ask this one question. I'll have all 3 of you answer it. I'm curious if you can share, what are some innovative ways that NASA is using data to solve real-world problems? Marilé, would you like to start?
Yes, of course. With the Globe Observer app, the app for the Globe program, we've noticed how a lot of you have been using the app in unique ways. So with the clouds portion, you can report different cloud types and what's on the ground looking up. But we also started noticing how people were reporting dust storms, smoke from nearby fires, other aspects that we never thought about when we designed the app or designed the protocol, the steps, and how to make the observations. So that brings up a new way of thinking about how to use those ground-based observations, particularly at moments when you cannot sense or detect those details from a satellite's point of view because there's clouds or other things blocking the view of those detailed observations. So it's been a huge deal to have those ground observations, even of just clouds. Um, but you can report land covers, mudslides, changes, water quality, mosquito habitats. All those very detailed observations have been quite large or quite impressive when collocated to the satellite's point of view. Two different ways of viewing one same Earth brings a lot of richness to the data.
The mind boggles. I'm thinking about just that idea of seeing clouds from both these directions, and kind of that like 3D database grasp of weather more broadly. Thank you. Same question. I'll pass it to Mark. Some innovative ways that NASA is using data to solve real world problems.
Sure. So, of course, we solve lots of out of this world problems. One of the places where those things cross over is near Earth asteroids, right? So you probably heard of this beast YR4 that at one point earlier this month had a 3% chance of crashing into the Earth. So one of our projects, for example, a Daily Minor Planet citizen science project, asks for help combing through gobs and gobs of data. They have thousands of detections every night. They load new data every morning and ask for help identifying near-Earth asteroids in images of the sky. We have all kinds of other real-world problems that we approach, and for example, the Earth Science Division saves lives directly
Mhm.
by tracing the path of dangerous mosquito larvae. So like Globe Observer Mosquito Habitat Mapper project um, was able to trace the progress of Zika across South
Mhm.
America. Obviously, mosquito-borne diseases are some of the biggest causes of death in the world. So people working on that project, I'm sure, feel very, very satisfied about their real-world problem connections. Um, I could go on and on. Our projects study how water budgets in lakes. They study how climate change is affecting kelp, how it's affecting songbirds, how it's affecting our um, our air quality. Um, there are 31 different active NASA citizen science projects, and many of them uh, bear directly on our quality of life.
That's you began rattling off this list of ways that these citizen science projects are worked, or, sorry, to which contribute to NASA data. And I'm gonna have a question about that in just a second. But I want to hear from Kevin as well about some innovative ways that NASA is using data to solve real world problems.
Sure. I'm liking the some of the chatter in the chat. I also wonder why mosquitoes exist, but that's okay. You know, the amazing thing about all of this information that we collect is that you can use it for really, really unknown reasons, at least when we initially launch them, right? We don't launch scientific missions because we're just guessing. We launch them for very specific types of investigations. But what we don't know is all the other things that we can do with that data, right? So Mark was talking a little bit about water budgets around the world. And like one story that I like to tell is we launched this mission called Grace about a little over 20 years ago now. And Grace monitors or measures gravity, and it measures, and when we launched it, we thought it would just measure the gravitational field of the Earth, and you wouldn't need to update that very often. But what we didn't know is that over time, you know, small changes in gravity tell you where groundwater is located, right? And it tells you the health of aquifers and how those aquifers are interacting with things like agriculture, and how people are using water to live their daily lives. It tells you a lot about the health and the welfare of glaciers. It tells you the salinity content in very broad terms of the oceans. So what we found with all of these observations is that we can do things that are unexpected. And I think the power of the community like this is that you have perspectives that will allow us to look at even more unexpected discoveries. Now, in terms of some of the things that I can specifically talk about besides earth science, and earth science certainly has the most users around the world, right? Because we all live here, and there's a lot of different types of measurements that we do and we continue to do of the land, of the oceans, of the ice, of the atmosphere. Um, and we have, I think, over 25 satellites up today that just look at the Earth and all the various components and how they interact in the systems. But we also look at the sun, and the sun is an incredibly important, I know, star for us all, in that it provides us with the energy that we need to you know, have photosynthesis and basically live, right? But it's also a dangerous star. It can kind of have coronal mass ejections. It can do other things that we also need to be aware of. So we monitor things like space weather with the Solar Dynamics Observatory and some other instruments. We have instruments that look at the moon, right? And as we talk about like a lunar economy, as we talk about exploring the moon and exploring Mars, we have measurements out there, and all of that information is available for anyone to come and take a look at on this call or otherwise. And I think one of the big things that we're doing is we're really trying to figure out how more people can participate in the use of that information. So we are now applying things like foundation models or foundation models for earth science, foundation models for lunar and solar science as well, which apply AI techniques to make it much easier for more people to participate with those kind of AI workloads. So if you are familiar with Hugging Face, which is a website where you can go and download models, you'll see on there we have a couple of different data science models for weather and climate using our Mera 2 products that you can go and take a look at. You can also download our harmonized Landsat Sentinel products. It's called the Prithvi HLS, I think it's called. And that allows you to take a lot of the forward stream of our data, the data collection that we do every day, and make your own applications from it. We're currently working on other things that allow you to process and look at Solar Dynamics Observatory as well. Again, the name of the website to download kind of those AI models is called Hugging Face, and we can put a link in there a little bit. But yeah, we are doing a lot of things with the data that we have, and we are looking for more and more people to access this information and use it in ways that they want to do it for their own types of research.
I appreciate you all sharing those examples. And it sounds like what's exciting to me is obviously the known ways that we're carrying out these experiments and generating data to solve problems that we know, but the unexpected, the surprise data that we're uncovering, and the novel ways that we're able to solve new problems or offer new solutions, I think is really exciting too. Again, I appreciate you all sharing. I want to, Mark, as I said, I want to turn back to you and learn a little bit more about this phrase you used, citizen science. What is citizen science?
Oh my gosh. Well, first of all, it has nothing to do with it has nothing to do with the word citizen, really. So the early days of citizen science, someone had this concept of citizens of the world, right? And kind of put that together with science to try to express what we do. NASA citizen science projects are excellent NASA science projects that rely on volunteers. So if you participate in NASA citizen science project, you're doing something that we can't really do so well without your help. And these are all projects that have passed rigorous peer review, and more than 500 of our participants have become co-authors on published papers as a result of their involvement in these projects. Yeah. We just, last week, for example, we just had, every now and then, one of our volunteers becomes the lead author on a paper. I just got to read one of those last week. So congratulations to Michiharu Hyogo if you're out there. Really cool paper about a star that has a low mass companion to it. Anyway, what it is it's sort of like it's open science super deluxe, right? So there's lots of publicly available NASA data, and in the Citizen Science Project is a place where you can go and receive training and receive tutorials and receive small chunks of a scientific problem that are a great place to start if you want to ramp up learning about a scientific field. And our citizen scientists do such a wide variety of different things. They deploy sensors, they read the professional literature, they write software, they take water samples, they so they collect data and they also analyze data. So often we'll put data online and we'll ask people help marking it up. Is this really a gamma ray burst or is this trash? And then often many of our participants go on and attend scientific meetings. We've had volunteers who have gone on observing runs with us to telescopes. We even had recently volunteers who won major professional prizes from our professional scientific societies. And we're just getting started.
Yeah. How do you engage people and motivate people to engage in these programs?
So the motivations, I think, are there are people are interested in a particular scientific topic. So a lot of people on this call I see are interested in black holes or Mars, right? You might Google Mars and you might discover that we have a project called Cloud Spotting on Mars, where you look at data from Maven and search for these arcs, which are the signatures in that are radiometry picks up of clouds as they go above the horizon and below the horizon with respect to the orbiting spacecraft. Or you might Google black holes and find yourself at Burst Chaser, which is looking at the largest explosions in the universe, which some of them are caused probably by neutron star collisions. Others are probably caused by black hole collisions. So this is one of the few ways that we have of interrogating what's going on really close to a singularity. So people are just interested in this stuff and they find it. And then what blows my mind is reasons people stay with it and the way that participating in these projects changes people's lives. And I'm gonna, do I have time to go into that? Do you want to come back to that later?
Hold on, let's put a pin in it now.
Okay.
But if your mind is blown, I'm sure mine will be as well. I do want to pass the ball back to Marilé. I understand the Globe does some citizen science work as well. I'm wondering if you could share some of the most impactful findings that have come from some of those citizen science projects.
Yes, thank you so much. Mark mentioned some of them, right? With the Globe Observer app, you can monitor habitats for mosquitoes. And if you add a microscope to your phone, to the heart right here, you can try and identify the larvae and see if it's a disease-causing mosquito larvae like Zika. And then do the service in your community of if it's in a plant or something that you can throw the water out so that people in the future don't get sick from those larvae turning into mosquitoes. In air quality and the atmospheric sciences, which is my background, we've been able to use data from people that go on excursions, like to the Arctic and Antarctica, and ask them to take photos in areas that not a lot of people get to take photographs, and really try to understand what's happening right above the surface. Antarctica is one of the most stormiest locations. It's still on my bucket list as a cloud scientist, if you think of it. But even with LiDAR detections like Calypso, it is really hard to see if it's or detect if it's a cloud or haze right above the ocean surface. There's been these signals that are hard to determine, but with people right there on board the ships, they can take observations on the horizon and give researchers then that advantage of seeing and understanding what's happening. And looking into the data, we've discovered that some of it is aerosols or dust, things in the atmosphere and the air that are traveling from nearby continents and getting all the way down there to Antarctica, which is really interesting to note. Other things, we are about to start working with the Civil Air Patrol, which are part of the U.S. Air Force. These are cadets and adults and that have a passion for flying and airplanes, and maybe some of you here have a passion for airplanes. One of the things that we want to understand more as a world, and not just here in the US, are the clouds that occur when the airplane passes through high altitudes in the atmosphere. It produces high temperatures, so it warms it up, it increases the humidity, and it can cause some clouds to develop. We can detect these from the satellite's perspective, but we don't know the altitude, we don't know specifically the humidity levels or anything like that. But looking from the ground up and knowing how to track the airplanes, we can get that information out and then compare it to climate models, weather models, things like that, and better predict what might happen later on. Um, we can also then work with other groups that are working more in the engines of the aircrafts or the fuel types of the aircrafts and see if there's ways to reduce that probability of producing clouds or affecting the atmosphere at those high altitudes in the troposphere. I know that there's other layers, but all the action in my head happens in the troposphere, which is where all the weather happens. And like I said, the dust storms, there are areas that you would think dust storms would occur. Like we get a lot of observations from Islas Canarias, right, right north of Africa near Spain. But there's also dust storms like in Indiana or areas like that where farming has just been subsided and then all that let's say a cold front passes with really strong winds and then all that dust gets picked up and it causes serious issues. And unfortunately, some people could perish or get injured from those. Those are also sometimes hard to detect from a satellite's perspective because of how quick they can be or because there's clouds covering the view of the satellite from what's happening on the ground. So again, your perspective from the ground, from your specific location can be so powerful to understand what's happening in general and put it into models, protecting people from other dangers and reporting things that nobody else can see from a satellite's perspective.
That's so rich. I think for all of us here on this call, the idea that we can be scientific instruments ourselves, right? That the satellites, while they're so powerful, such advanced technology, it sounds like they rely on us as well to triangulate this data to offer more specific, more accurate observations, and it sounds like predictions as well, which can be life-saving. Wow. I have the Globe Observer app, and I think it's cloudy right now, so I think after this call, I'm gonna have to go see what these look like cirrus to me, but who can say?
Yes, please. But I'd rather you make an observation, even if we're looking for great, not perfect, or good observations, not perfect observations. I'd rather that you send in your observation than not send it and thinking that you're not excellent or you're not a trained spotter and it's just going to damage the project. A lot of people sometimes don't participate on the citizen science projects thinking that they're just going to put in very bad data. And really, I'd rather have the data point than not have it at all because you don't know what unique perspective you might bring. So I'd rather have good data than perfect data, if that makes sense.
It definitely does. And it sounds like there's in that phrase, citizen scientist, the emphasis is on citizen.
No, 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 no. Citizenship, participation doesn't require citizenship in any country. The emphasis is on everyone.
Gotcha. Emphasis on everyone. I love that, Mark. Thank you for that. I do have one more individual question to ask. We're going to zoom out after this to ask some more whole group questions. But Kevin, I'd love to hear from you. If you could share some of the biggest trends in data science that you believe will shape the future of space exploration.
Sure. I think AI is really pushing the boundaries of what we can do. I think as we become better at using those tools for especially time series observations, so those are observations of the Earth or of the sky, or anything where we can use things like vision transformers to look for really, really intricate patterns in these massive amounts of data that we collect every day. I think that that's going to be really important. I think how we advance kind of the speed of discovery and the availability of the research results is critical, both for expanding how many people can contribute to science, but also how easy it is. So I think that there's a lot that we can do from the data science side. I think that there is a lot of ingenuity out there too, in kind of the maker side, where they can help make or deploy new types of small instruments and kind of get those results in and look at how they, especially in earth science, relate to what's going on in the ground. You know, and I think that that combination of really kind of asking hard questions, looking at kind of the data science AI world, those are all areas that I think really will have some practical benefits for the people that participate in them, because these are, you know, valuable skills even outside of just science.
Mm.
But they're also, I think, really interesting problems, right? So I think that really drives kind of the discovery, that drives the interest and the ingenuity around the world. So yeah, let's hear what everybody else has to say in terms of where they think we're going.
Yeah, please, let's open up to the floor. If either of you have an opinion or a perspective about big trends in data science that you're excited about, or you think will be formative for the future of space exploration or Earth observation.
Do you want to take that, Marilé?
Yes, I love the idea of so I'm a researcher, but I'm also an educator, right? So I'm a trained researcher, chemist, and then atmospheric sciences. But my passion is to get everybody involved in sciences, especially those that think that there's an obstacle for them to get into science. So I love the idea of using artificial intelligence, machine learning techniques, even in identifying clouds and the photographs taken by citizen scientists or volunteers. And that might seem like a very easy thing to do, and it is not. There's many reasons why. Clouds are in the background in the photograph, not in the foreground. So it's usually something that's far away, not close by. So you have to take out the foreground, which is not something that you tend to do on a photograph. The other thing, when I was a researcher, we called this the twilight zone. When does a cloud actually start? Like, what do you call a cloud? I know, I'm blowing your mind. I know, but when I was in research, I did aircraft aviation, so I flew inside and outside of clouds. And what value of humidity or water content would you say you're now inside of a cloud or not? Similar in a photograph, it can be kind of like my cloud right here. It can be pretty hazy. So is that the cloud? Is this the cloud? Is this the cloud? So in color, I love looking at the radiation effects in the atmosphere. We get a lot of beautiful colors, but clouds are whitish, gray to white. So all these items make it quite difficult, make it into a difficult thing. But there's a lot of tools out there that you can use to start learning about it and start applying one technique. And what we found working with first and second year undergraduate students and other professors is that different techniques will help you identify different cloud types. And then you can dig more into why that's happening. And so I'm excited about how there's techniques that you can use and apply pretty quickly. Google has some great ones to start teaching you about machine learning, artificial intelligence. Use just a cloud photo and you'll discover that's actually a bigger deal than it is right now. But then with that, you can apply it to other things and try to detect issues, find people, detect like I was talking about the larva, the mosquito larva, that's a big deal trying to decipher which larva do you have in the photograph. So as you start with simple photographs, you'll start learning about different techniques and then applying it to other things and then being able to maybe even save lives in that.
I absolutely love that. Who knew a cloud could be so existential? My mind was just blown. Mark, you did promise me that another mind blowing. So please, I'll pass the ball to you.
So, AI has become so prevalent these days that pretty much all of our 31 projects have some AI component to it, whether it's a clustering algorithm or, many of them have volunteers themselves have undertaken to use AI as part of their research.
Sure.
So it's everywhere, right? And some of the cool applications that I've seen that surprised me are that sometimes we'll have a big data set, and there's going to be in every data set there's the easy cases and the hard cases, right? And so you might use AI to do the easy cases and then send the hard cases to humans.
Mm.
Another approach is that people are using AI to analyze comments that volunteers make. So if people are interacting together on a bulletin board, you can use AI to quickly sort through that comments from tens of thousands of people at once to make sense out of them.
Sure.
So it's just cropping up everywhere and mostly changing our lives for the better, I'll say.
Mostly.
I think there's some other things too, though, that people can work with, right? So we've seen a lot of work in terms of kind of reproducibility and sharing, like along the lines of Project Jupyter, if you've ever heard of that, which is a Python notebook environment where people can really like this type of work can be very, very hard to get into, right? And so anywhere where people can kind of share what they're doing and share like their read routines and their QA routines on the data that they bring together, share their experimentation in terms of the coding that happens with this is really critical too, right? So if you haven't heard of Project Jupyter, you might want to go check it out, or Binder, My Binder, those types of things, because that allows you to find communities that you can work with to maybe help you along some of these pathways, to help you with AI, to help you with any of the program which is critical for the work we do today, right? So this isn't go off and find it yourself. I am sure that there are communities. I know that there are communities out there if you're interested in specific areas.
Sure. Thank you all. I want to ask one more question of this group, and then I'll open the floor to some Q&A from questions that we're receiving from the audience. Folks, already more than a dozen great questions have come in. Please continue to share those in the chat and in the Q&A function so we can ask them of our experts here. But before I pivot to that, I'm curious, I'm wondering if I can get your best pitch for citizen science. Why should the public get involved with citizen science efforts with NASA? Marilé?
Yes, thank you. And I was alluding to it earlier. Your point of view from where you're at is unique and precious and can bring about new perspectives, new ideas. And so talking from the globe perspective, your land cover observation, your cloud observation is unique and cannot be easily reproduced. Your background, what you've studied, or your experiences, no matter what it could be you're an artist or you like computer science, those perspectives bring you to work in a problem or a challenge and look at it in a very unique way than others that are coming from it with different backgrounds. So your background and your point of view are unique and hard to reproduce. And that's why it's so important and so powerful for projects like the GLOW program to have volunteers constantly making observations and looking at the data and making new discoveries.
I love that. The impact of the subjective and his contribution to the objective projects going on. I love that. Kevin, how about you?
So there are so many different ways to be involved with NASA, to be involved with science. And I'm sure that there is a spot for everybody on this call to be involved with what we do. You know, so when we talk about citizen science, when we talk about science in general, I think as Mark kind of likes to call it, because citizen science is real science. Citizen science is science. You can be involved in it, right? We try to make tools and tutorials and other things and data available, so that the creativity of everybody can be applied against some of the most pressing problems that we have today, to make the groundbreaking discoveries of tomorrow. And you know, if you don't see us doing it, you know, we can't do everything within NASA, but you certainly can build communities yourselves, and leverage the things that we have put out there and built, and maybe contribute back into our software domain, into data collection, for validation, like we've been hearing with Globe, or helping us parse through the amazing amounts of information that have been collected, looking out beyond our own solar system. So you know, I think the pathway to discovery is going to be different for everybody, and what your passion is going to be different. And I think that you can find yourself a home in a lot of the things that we have at NASA. And I really do look forward to continuing to see those amazing discoveries, especially out of things like space apps.
Mark, anything to add?
Say, come for the chance to do something real and lasting and really have an impact. You know, we recently had 4 of our citizen scientists who had asteroids named after them, right? Because they discovered asteroids.
Wow.
I mean, you just can't beat. That's the thrill. It's the thrill of citizen science is the same as the thrill of any science. It's a roller coaster ride. Sometimes there's dead ends, sometimes there's heartbreak, and then sometimes there's just this rush because you changed the universe.
Wow. I need to do more. What a call to action. You changed the universe. I want to pivot, as I said, to these audience generated questions. The first, actually, I'll start with a comment from Kaushik, who is in the chat, who says, I know there's a big focus on the space side of things, but as a private pilot, thank you for touching on aviation performance and aviation weather. Pilot observations are also useful data that can be used for predictive analytics and mission planning. People often leave out the aviation portion of aerospace, so thank you. To our first question, Charlene, she asked, what's the right balance between the use of AI and citizen scientists for the questions that we need to answer? What are each best at, and how can they work best together? And I open the floor, whoever thinks they have a strong answer to this. Please.
Sure. So citizen science is cutting edge science. And if you're going to do it right, you have to use the best tools that are available. So if there's a tool we've got to try it. And that's the balance right there, is we do the science the right way. And if that means it's all entirely AI one day, so be it. And if it means that there's no other way to do it than to send Marilé out to the Sahara to collect cloud observations with 10,000 of her closest friends, then that's how it has to be.
A party in the desert.
I'll go to
Um,
that. I'll go
please.
to that party. Yeah, but it's a very interesting question because I'm reminded that technology is great, but it's not perfect. So um, we use it as a tool, but it's not the solution. That's how I would find the balance for it. Think of it as a tool in your toolbox to try and find a solution, but it's not the ultimate solution. So like Mark was alluding to, you'll still have some portion it'll have to be checked or reanalyzed, things like that. The example that I gave about clouds, you can let the machine try and do multiple types of clouds, and at some point it'll crash, even if you do it as machine learning, because there's just certain aspects that our eyes, as our instruments, can detect in a photograph that the machine will not be able to detect, because we're doing so much more with our brains that the machine just cannot
Mm,
replicate as well. But it's great. We have millions of photographs of clouds, sky view. So you, again, it's a great tool to determine, is there a dust storm in this photograph? Is there something new? Is there smoke from nearby fires? But it cannot be that standalone, at least not yet. And so that's where the balance comes in. Think of it as a tool, not the solution.
sure. I really appreciate you offering that example. Another question I was going to ask, somebody asked for a specific case where AI did the easy cases and then a human, came back through to do the hard one. So I appreciate you reading my mind there and offering that. A question comes in from Nabiha. They ask, what are some common resources to get involved in citizen science? I know we talked about the Global Observer app, but are there other links or resources or tools that folks can use to begin to get involved in doing citizen science with NASA?
They're all at science.nasa.gov/citizen science.
Awesome.
And we are in the process of adding more. We probably add one about one a month.
Okay, cool. Sounds like a lot of opportunities for folks to get involved. I guess I'm curious more about that. Is there like a level of phone access or internet access or technology that folks need to have in order to engage with these resources? Or I imagine there's a gamut.
Yeah, most of them, you have to have access to the internet, at least at first. And you need some kind of laptop, though more and more of them, you just need a smartphone.
Mm.
Sometimes there are projects where you can go to a community center and contribute. Like there are projects which involve telescopes that might be available at your library or at a community college. Borrow those and go out in the backyard and take some images of stars and check for exoplanets around them.
I love that. The more and more we can get folks involved in the community, the better, as far as I'm concerned.
Some of them also, I should mention, this really cool project we have about. Sorry, you got to stop me, or I will just go and go. There's a really cool project which is done in high schools. So high schools receive a kit where they build sort of like a terrarium, and then they get seeds,
Wow.
and they do growth experiments on different varieties of plants under space-like conditions. The idea of picking crops that'll be useful for the ISS or for missions to the Moon and Mars. It's called Growing Beyond Earth. So there you go. You don't even need a computer. You just show up at school.
Just go to school. For all the kids on the line, so you heard it here first. Go to school. We've had a few more questions come through. They feel a little esoteric, and so I appreciate these excellent perspectives. Folks are asking about human enhancement and genetic engineering. Folks are asking about specific uses of AI in projects that I can't pronounce, and I'm at the limits of my knowledge here. So I think it might be best if I share those offline so you can respond as appropriate. But I want to thank you all again for joining us in this panel session. You've been awesome. you've been knowledgeable, you've been experts, and we're so grateful that you were able to join us at the Collective Genius Summit this year. I would love if in the chat, folks can share their appreciation for our panelists today. I'm so grateful. I know our team is so grateful to have you. I think that we have a bit of reflection coming up, but I would love if you could stick around. I know folks in the chat are going to be taking some opportunities to think about what they've heard together. I see thank yous rolling in from Argentina, from Brazil. Folks ask specific questions about how their space agency can get involved. I think that the energy is so powerful for the work that you do, as these citizen scientists on the line are obviously plugged in, but I think this is just the beginning of what's possible as these folks spread the word and share these resources around their communities. So again, so grateful for everyone. In the chat, I would love if folks could use one word to describe this panel. Try to limit yourself to one word that describes this panel. Amazing, fantastic, fascinating, empowering, informative, inspiring, galvanizing. Come on, GRE words. As you can see, folks, Mark, Kevin, Marilé, your work inspires. We're so grateful that you were able to join us. We have one more reflection question. For this, I'd like to do another chat storm. So again, hold off on sending your response until I give the order. For now, just type and wait. What is the biggest insight you're taking away from this panel? Don't send your answer just yet. Let's take a minute to think. What's the biggest insight you're taking away from this panel? Take about 30 more seconds to get your thoughts together. In about 10 seconds, I'm going to ask us all to hit send. Counting down from 5. You know NASA loves to count down. 5, 4, 3, 2, 1, and send. The power of citizen science. We all have the opportunity. So many great opportunities. If there was ever a doubt, it's been confirmed today that clouds are amazing. Indeed, it has been. That we can know more about getting involved, about future projects, about AI tools and emerging technologies. Perspective and observation are the wins. We can all contribute that. You're absolutely right, Rob. Panelists, before I let you go, I want to open the floor back up to you one last time. If you have any other concluding thoughts or remarks you want to leave with our audience.
I'd just like to say thank you for listening to us. And we've got a bright future ahead with NASA's satellite data and scientific investigations. Come and participate.
Well said, Kevin.
Yes, definitely. There is a spot for everybody and an opportunity for you to make an impact. So always keep coming back and checking what is new. Like Mark said, there's a new project about every month or so. And so always keep checking the NASA website and the space apps opportunities.
We're so, so grateful. I can't say it enough that you take your time out to share with this community the awesome ways that NASA has for folks to get involved in doing citizen science. Folks on the line in our collective community, we have some opportunities tomorrow to have some customized engagement in our connection session. So with our last chat question, I'm wondering, what from the panel today would you like to learn more about or dive deeper into over the Collective Genius Summit? You shared some of what sparked your interest, but what specifically are you hoping we talk about or cover in the rest of our programming? Let's make this a chat storm. In 30 seconds, we'll send. In 30 seconds, we'll send. I didn't expect to be doing this much counting down. In 15 seconds, we'll send. Already a lot of plugs for Globe. Fortunately, Globe's own Becky Boger will be joining us for our workshop tomorrow. Everybody hit send. What are you excited to learn about? The Artemis mission, upcoming missions, how to use AI effectively for citizen science, possibilities for machine learning, Globe, the most effective ways to collect data. Folks will be gathering these perspectives and we will be using them to shape our connection sessions. So tomorrow, as you return to for day 2 of the Collective Genius Summit, we will be using these to shape some of the conversations we have. So we're really grateful for your participation throughout the summit. Thanks again to our incredible speakers, Tom, Marc, Marilé, and Kevin, to our incredible audience for their participation, their commentary, these excellent questions. We are going to take a bit of a break. But when we come back, you have some time. When we come back, we have some excellent content to share with you all. In block 2, which begins at 7 p.m. Eastern or midnight UTC, we have some super exciting lightning talks from our collective cohort. Data in Action, stories from the NASA SpaceX collective cohort, features 4 of these folks, and they'll be sharing the projects that they've worked on throughout the course of the year. I know we're excited to hear from them, and I know they're excited to share with us as well. Beginning at 8:30 p.m. Eastern or 1:30 a.m. UTC, we have our final panel of the evening, Making a Difference Through Collective Wisdom, featuring Dr. Emily Salai-Glassman and Dr. Merle Ballard. Before we go to our break, connection board, which has just been put in the chat, will be open throughout the summit. Will be open throughout the summit for you to populate ideas or projects, asks, and offers. We've already seen some folks share some LinkedIn connections, share some links to websites and articles that are informative and helping us develop our skills as citizen scientists. Please continue to use that. The board will be open throughout the course of the summit and through the weekend as well. Just as before, the line will be open until the hour. If people want to connect over chat or ask any questions. Thanks again, everyone. See you in a couple of hours. We really hope you take an opportunity to stretch, go outside, look at the clouds, if you will, and come back refreshed and ready for our second block of programming. Thanks again, everybody. See you in a couple of hours.